Hey, welcome back to Algebra 2. Today's lesson is factoring by grouping, okay, 2.8. So we've talked about three different types of factoring so far. We've talked about the GCF, TOPS, and just factoring trinomials. All right, so greatest common factor, difference of perfect squares, and trinomials. And we've also done complete factoring, which means 2 words, 2 steps. But today we're going to look at factoring by grouping. And this is really the only way that we can factor larger degree polynomials like degree 3, degree 4, even degree 5 or 6. Um, so and it basically works by looking for the structure in the problem. So we're going to start with some exercises that will basically, this will be our second step, but we're going to start with it first. And you'll see what I'm talking about when we get to exercise 2. So exercise 1 says factor a binomial common factor out of each of the following expressions. Write your final expression as the product of 2 binomials. So what I'm hoping you're realizing here in exercise 1 is that if you take a look at A, you're going to see that there is a common factor, but it's not like a monomial or a number or a coefficient like you're used to seeing. Here we're seeing a binomial common factor. So we're going to be factoring out that common binomial. So in other words, what I'm saying is the 2x plus 1 is going to be our common factor. So basically, what we're doing is we're dividing out 2x plus 1 out of each one of these problems, these terms, I'm sorry. So these cancel, and we're left with x plus 7. So we just factored that by grouping. We kind of, like I said, with this exercise 1, we're kind of missing the first step, and we're given the second step. And like I said, when we get to probably exercise 3, you're going to see that, not exercise 2. So we're going to keep that same thought process in mind as we look at B. So as we look at B, we have this one and we have this one here. So you can see how it's pretty easy and to see that the x minus 2 is what we have to factor out. And we're going to divide out that x minus 2 out of each one of these terms. So these cancel. So what am I left with? 5x minus 4. So how are we doing? So far, so good? All right, so let's look at C. So when we take a look at C, again, we can see that, no pun intended, we can see and see that x minus 7 is going to be our common binomial factor. So as we factor out that x minus 7, or divide out that x minus 7 out of each term, these cancel, so we're left with x plus 5. Now, this plus right here is going to be this plus right here. All right, so x plus 5 plus x minus 7. Now you could keep the parentheses around these. In other words, you could within here, we could put parentheses here and here if you wanted to, but it's not necessary. So let's just take that out and do it like this and say x minus 7 times, now we have x plus x, which is 2x, and positive 5 minus 7 is minus 2. So a little extra step in that one. Moving on to D. Remember, if I'm going too fast, just pause it so you can write things down. So in D, I'm hoping you recognize that x plus 4 is our common factor. So we're going to factor out an x plus 4 out of this side and an x plus 4 out of this side. And when we do that, these cancel, and we're left with 2x plus 8. Now beware, see this minus sign here? This minus sign is this minus sign here, but then don't forget that that x minus 2 really needs to be in parentheses. Or you can recognize that you need to distribute it right away, and you could have come out with 2x plus 8 minus x plus 2. And we have one more quick step to do, and that's just to combine like terms into x plus 10. Okay, so moving on to exercise 2, write the expression as the equivalent product of binomials. So, even if it doesn't say factor this by grouping, then you can hopefully see that the x minus 3 is going to be common to both of these. So factor out that x plus 3, and then what do we have left over? And again, if it helps you, and sometimes at the beginning it is really helpful to do this, even people at the end feel it's okay to do this, cancel. And what are we left with? We're left with the x minus 4. I said 4 and I wrote 5. So x minus 4 plus 5. So one more step, x plus 3, x plus 1, after you combine these two. Good? Okay, so now once we see the structure that we're supposed to get to when we're factoring by groupings, now we can move on to exercise 3, because this is basically what they're going to look like. All right, they're basic. In this case, notice they're degree 3, they're degree 5 in C. All right, so we're going to look for the structure in each half. So basically what I'm telling you is we're going to break this up. We're going to break this one up, and we're going to break this one up, and look for the GCFs in these. So what we're going to do is we're going to create what we had in exercise 1. So the first half here, 3x cubed plus 2x squared, you're going to pull out an x squared, and what do we have left over? 3x plus 2. Now what we want to try and do is we want to try to get this 3x plus 2 again in the second half. So if I factor out just the 9, I'm going to end up with negative 3x minus 2. But if I factor out a negative 9, then I'm going to get positive 3x plus 2, and that's what I want. I'm looking for that same common binomial. Right? So, again, if it's helpful to you, negative 9, negative 9. So you end up with that. So basically what that means is now we can factor out that 3x plus 2. And when we do that, what do we have left over? X squared minus 9. Now I'm hoping at this point now, red flags are flying everywhere because x squared minus 9 can be factored one more time. So we have the 3x plus 2, and now we have x plus 3 and x minus 3, because x squared minus 9 is the difference of perfect squares. And this will always say, see where it says to completely factor the following expressions? So that means that it wants it in its completely factored form. It does not want it to be partially factored. So this right here is partially factored, and this right here at the bottom, this is completely factored. Okay, moving on to B. We're going to do exactly the same steps. If it's okay, I'm just going to put a little squiggle here so we know where we're starting. So we're going to pull out the GCF of this side, and in this case, we're going to pull out the GCF of this side here. So what goes in? We can take a 9x squared out, which leaves 2x plus 1. Okay, now let me just show you this for 1 second. Drop my pen. I just want to erase this so I can show you what I'm doing here is I'm dividing this side by 9x squared, and I'm dividing this by 9x squared. So that's what gives me this part right here. When you have 9x squared divided by 9x squared, that gives you that 1 that's right here. So don't think it just goes away. You have to repeat it. You have to put 1 there. So 2x plus 1. So now the next part, if I want to keep a 2x plus 1 here, and I have negative 2x minus 1, I can factor out a negative 1. And that makes my 2x minus 1, a negative 2x minus 1 into a positive 2x plus 1. So now I can factor that out. So I can factor out the 2x plus 1, and then what's left over? 9x squared minus 1. Again, we have one more step here because 9x squared minus 1 is the difference in two perfect squares. So make sure that order counts. So the 3x must go in the first position, the 1 in the second position, and plus and minus between them. So how are we feeling so far? Oh, they're not that bad. Easy does it. Okay, let's go on to C and D. All right, C. These two and these two. And it always works out that way, where they're kind of next to each other. So, because they give us in descending order, which is always kind of nice. So pull out, in this case, an x cubed. And then we have an x squared plus 4 left on the left-hand side. Now, don't think that x squared plus 4 is not the difference of perfect squares. It's the sum of perfect squares. So remember, we can factor a DOPS. We cannot factor a SOPS, a sum of perfect squares, only the difference of perfect squares. So if you see in the second part, we can factor out a 2. And luckily enough, and believe me, this is not by coincidence, we get x squared plus 4. This leaves us exactly where we had it in exercise 1. So we can factor out our x squared plus 4. And we're left with x cubed plus 2. Now, I would love to be able to factor this some more. It feels like it should be able to be factored more, but it can't be. You're done. So just because you want to factor it doesn't mean that you can. Okay, so let's look at these two, this one and this one. So the first half, we're going to factor out a 5x squared. We're left with x squared plus 1 plus 20 x, oh, I'm sorry. This is not an x squared plus 1. See, now that's what I'm talking about. See, I get x plus 2 here. When I do that, I know I must have made a mistake in the front because I need these two to be the same. So I don't know where my brain was when I just factored this one, but this one is not correct here. When I take out a 5x squared, 5x squared, 5x squared, I get x plus 2 here. So just it goes to show you that not everybody makes everything perfect the first time around. You're allowed to make mistakes, and you're gonna make mistakes. I make mistakes all the time, but I recognize what it has to look like because I know that I have to factor out that group. In this case, it's x plus 2, and then I'm left with 5x squared plus 20. Now, factoring completely means I can't leave that 5 in the 20. So what I'm going to do is I'm going to factor out that 5, and I'm going to get x squared plus 4, and then the x plus 2 comes here in the back. So do you see what I did? I took this part right here, and I factored that over here. I took the 5 out. I was left with x squared plus 4, and I'm left with x plus 2. Now, at this point, I might have asked myself, gee, I wonder if that was supposed to be an x squared minus 4. But no, it's not. It's an x squared plus 4. So in this case, it's definitely not a DOPS. But I might question that. Because a lot of times if it's telling me to factor it completely, somewhere along the lines there's going to be some more factoring that can be done. So just be careful when you're factoring by grouping, because don't force the method when it does not apply. All right, so exercise 5 is what we call an error analysis. It says consider the expression that explain the error made when factoring. All right, how can you tell that the factoring is incorrect? So how we start this is, here's the original polynomial that we were given. And then you can see what they did the first step. They first factored out a 2x squared, and they were left with x plus 5. Then they factored out a 7, and then they left with x plus 3. So they factored beautifully there. But these don't match, right? This one and this one do not match. You can't do any further. You can't go any further. This is as far as you can go. All right, because Lord knows this person started then factoring out the x plus 5 plus x plus 3, put the 2x plus 7, so what a mess, just a mess. So when you're factoring by grouping, you have to look for the same binomial in both sides. All right, so explain the error. What error? It was a mess. All right, let's just say the error was made when this person, I don't know who it is, this person, what did this person do? This person did not, I'm going to say did not use grouping. Honestly, it's such a mess. I don't even know where to start with where this person went. They just didn't use grouping. Because if they used grouping, they would have recognized, they would have said that if one was x plus 5, then the other binomial should have been x plus 5. Or if one was x plus 3, the other had to be x plus 3. Again, if it tells you to explain something and you're having a hard time, just write me a paragraph of what you think is the case. All right, I'm not going to take the time here to do that, but however you can make your point, make sure you're making it. Okay, I don't think that's it. I don't think there is an exercise 6. I think the next one is, as I'm right, independent practice. So rewrite each of the following. So this is basically starting with the step 2, and then we're going to move on. So until we see each other again, always make good choices and get your homework done. Remember, homework is so important. It's actually our time to practice things on our own without having them, told to us or copying it down off a board or from a neighbor or something like that. It's really important that you do that. If you do your homework regularly, then studying for tests should be a breeze. All right, see you next time.